Good morning. It's a great pleasure to be here. Thank you for organizing such an interesting event. So in the next half an hour, I'm going to share with you a summary of all the work that we have been doing since March of 2020 in a team that we call the Data Science Against COVID-19 team in collaboration with the Valencian government. The main objective of our team is to support in the public policy making and the public decision making through the analysis of data using advanced machine learning and data analysis algorithms. To do so, very early at the beginning of the pandemic, in early mid-March 2020, I reached out to the government because I had worked for many years on how to leverage data for social good. With the idea of creating a multidisciplinary team of experts working very closely with the presidency of the region to support them in their decision making. And my proposal was very positively received, and very quickly we created a team composed of researchers from most of the universities and research centers in the region. You can see that the map of the region and all the different members in the team. I had never worked with any of these people before in my life, and I had never seen them in person until very recently. So we have been working for more than a year just virtually using technology. And what is the main purpose for our team? So as I said, is to support in policy making. So ideally, we want the public policies to be based on evidence, to be based on data. But historically, there has been a big gap between the data sources and where the data is and the policymakers, because there hasn't been the capabilities to be able to transform the data into meaningful insights. And that's fundamentally the purpose of our team. So we divided our work into four areas. The first one is human mobility analysis, because of course, an infectious disease that is transmitted from human to human doesn't become a pandemic if people don't move. So modeling, quantifying, and understanding human mobility is very important. And we actually have been a pioneering region in using aggregated mobile data from the mobile network infrastructure. The second area of work is computational epidemiological models. So models that would predict the pandemic curve under the current situation, but also under different possible scenarios of non-pharmaceutical interventions or contact tracing capacities or vaccination. The third area is building machine learning-based predictive models, mostly of hospitals' occupancy and intensive care's occupancy, because those two were the most important healthcare metrics to try to model, so to avoid having saturation in the healthcare system. And then the last big effort is a very large-scale citizen survey called COVID-19 Impact Survey. It has more than 600,000 answers, and it's become one of the biggest surveys in the world about COVID-19. And still, the work of all these teams is quite technical. And as you see, there is still a gap between the output of all these teams and where the president and the policymakers are. And I think one of the key elements for the success of our team is the fact that we have this intermediate layer composed of Director General for Public Policies, so a politician that works for the president. She is also a member of our team. She's been coming to every single meeting, and we've been meeting every day for many months. And she's been helping out, identifying priorities, and more importantly, understanding all the results of our work and translating it into actionable insights and sort of political language that actually could be useful, to them. So I think one first take-home message from this experience is how important it is to have politicians and policymakers being members of teams of this kind to really make sure that the work is actually useful and is also used. Creating a team like our team is not easy, and that's why it hasn't been commonplace during the pandemic. There are many challenges, and we actually describe some of these challenges in this paper in Science Advances that we published at the beginning of the pandemic. A big challenge is that in governments and public administrations, there isn't really a digital mindset yet. There isn't really a lot of human resources capabilities that are machine learning experts or data science experts to be able to leverage all this data. There are also a lot of difficulties in accessing the data. The data is in different servers, in different systems. They don't talk to each other. Some of them are legacy systems, and it's really complicated to automate all of this and be able to analyze the data in a systematic way. There are, of course, concerns about privacy and data protection, but I wanted to emphasize that all the work that I will present today has been done using very large scale, anonymized, aggregated data, most of it publicly available data. So you can do a lot of useful things, even with really aggregated and anonymized data. There is usually a gap between where research is and where the real world is. And that's why it's so important to have also sort of like the customers of these kinds of projects, you know, the policymakers being part of the team. And then, of course, in the context of a pandemic, when you have to be making daily decisions or even like, you know, multiple important decisions in a day, if you don't have all these other elements in place, you can't really benefit from them because there's no time. There's no time to prepare all these things. It requires really fast actions. And maybe that's why our team has gotten a certain amount of international notoriety, and we were featured in Politico and in MSNBC in the US. In terms of the technical skills, everyone is a scientist, a professor, or a student in, you know, different fields within sort of like computer science, statistics, maths. The mobile data team is is an expert in data visualization, large scale data visualizations, in sort of like a spatial temporal data visualization. The computational epidemiological team has a number of statisticians and mathematicians and experts in computational modeling. And then the predictive modeling team has a lot of more hardcore machine learning expertise. And then the citizen science team has more expertise also in human-computer interaction and user studies. We've been working very intensely until probably the fall of 2020. We met every day since March of 2020. I schedule a meeting every day at 9:30 a.m. and I wrote a report every day by 5 p.m. with the predictions of the day and some of the important observations or you know, feedback, you know, for that particular day. We have a common GitHub repository, and we use Slack for communication, and we talk all the time using Slack. This is an example of one of the meetings. And as I said, we had never met in person until very, very recently. We have an official website and the government's website if you're interested, but it's in Spanish. So what have we done? So in terms of the mobile human mobility analysis, there have been two main reasons why this has been important. The first one is to help the government understand if the confinement measures were working, what kind of mobility was being the mobility that was the most impacted by the confinement measures, and which regions might actually not be very compliant with them. And the second reason is to model the impact of the reduced mobility on the progression of the disease. So to do that, we were appointed by Vicepresident Calvino, the pilot region in Spain, to be able to use data that was sort of like computed from the mobile network infrastructure by the Spanish National Office of Statistics in a collaboration with the three largest telcos. And we were able to analyze that data since March of 2020. This is an example of the Valencian region and sort of like the mobility in the region for one day. We built also a dashboard for the government so they could look at the mobility in every municipality and understand the incoming mobility, the outgoing mobility, how many people never left their area of residence, and so forth. What are some of the results? So at the beginning of the pandemic, we measured the radius of gyration to see what was the impact of the confinement. And we found that there was a 65% reduction in the radius of gyration. The radius of gyration is the radius of a circumference that covers the majority of mobility of a population. And that reduction of 65% was larger than the average in Spain. And that meant that if before the pandemic, before the confinement, the radius of gyration was 10 kilometers, because of the confinement, it went down to 3.5 kilometers. We did the analysis at different levels of spatial granularity, and temporally, every analysis was done daily. We had the data daily. So here we can see the smallest spatial granularity that we had the data for, which are these regions that you can see, these irregular shaped regions, these cells, and that was the smallest area that we had data for. And these regions were defined by the National Office of Statistics as follows. They had to have a minimum of 5,000 people living in them. So if there were municipalities smaller than 5,000 people, they brought together multiple municipalities until there was at least 5,000 people. And that's why some areas like the ones on the interior of the region are very large, because those are not very populated areas, and then they had to take multiple municipalities. Municipalities between 5,000 and 70,000 people have only one area, and municipalities that are larger than 70,000 people have multiple, they are split into multiple of these areas. For each of these areas, we had the number of people that never left the area for more than 2 hours a day, and that was their area of residence. So this is the area where they slept. And we used that information to measure the success of the stay-at-home campaign, which was a campaign that the government launched to encourage people not to move and not to travel. And we found that during weekdays, 88%, and during weekends, 92% of the people didn't leave their area of residence in the Valencian region during the first period of the pandemic, between mid-March to the end of April of 2020. So it was a very sort of like high levels of compliance of the sort of like a stay in your area of residence sort of like requirement. This is a visualization of all the days during that confinement period, and the greener the map, the larger the percentage of the population that never left their area of residence. And you can see how at the very beginning of the pandemic in mid-March, the map is still a little bit yellow. This means that there were a smaller percentage of people staying in their area of residence. And then when they implemented the 2 weeks where there was no labor mobility except for essential services, then the map became really green. Like there was really a massive stay at home sort of like period. And then slowly it went back to having a little bit more mobility, but it's still very high levels. I mean, the yellow is still like in the 70s or 80% of people not leaving their area of residence. As I mentioned, we did all the analysis, and we do all the analysis at different spatial granularities. And one particularly relevant one in Spain is called the Department of Health. A Department of Health is the geographic region that is served by a hospital. And in the Valencian region, there are 24 departments of health. So here we see the percentage of people that never left their area of residence per Department of Health. And we can see that is fairly similar in most departments of health. We also analyze the labor mobility, and here we compare the labor mobility during the confinement with the labor mobility of a day before the pandemic in November of 2019. So what the map shows is the drop in labor mobility when compared to November. And we observed that on average, there was 60% fewer people displaced during the day because of going to work than there were in November of 2019. And that was the average for the entire first wave, so to say, of the pandemic. Because we have incoming and outgoing flows, we can also compute what we call activity levels and compare the activity levels to the activity levels that they were in November of 2019. And again, the main observation is that there was a significant drop in activity levels. In the map here, it shows the drop the week of March 24th, which was the week before they canceled labor mobility. And again, the greener the color, the larger the drop. If it was green, it would be like a 90% drop in activity levels. So we see that the map is not really very green at the beginning of the pandemic. But then when they implemented the 2 weeks where there was no labor mobility, then indeed the activity levels dropped very significantly, and pretty much everywhere there was a drop of 80% or larger on the activity levels. This is the same metric, the same variable, but measured for each of the 24 departments of health. And we can see in yellow the activity levels during the confinement, and we can see in orange the activity levels in November of 2019. So as you can see, it's a huge drop in every department of health. Because we have the mobility and the flows of mobility between all these different areas, we can apply a community detection algorithm to all these flows to identify what we call sort of like self-contained mobility communities. So that would be geographic regions that have a lot of inner mobility but are not very connected to other regions. And identifying these communities of mobility is important when defining partial confinements, when you don't want to confine the entire region, but you want to confine some areas within the region. So applying this community detection algorithm, we identified 14 macro health zones or mobility communities, which, as I said, are regions that are very self-contained but don't have a lot of connections with other regions. And that was very useful for the government to define partial confinements. The second area is developing epidemiological models. So models that will not only predict the evolution of the pandemic but under the current situation, but also under possible different scenarios of non-pharmaceutical interventions or contact tracing capacities. We have developed 3 different kinds of models. The first one is a SAIR metapopulation model. This is a traditional compartmental epidemiological model. It divides the population into 4 states, which are the names of the SAIR acronym. So the population can be in the susceptible state, and initially in February of 2020, all of us were susceptible of getting COVID-19 because it was a new disease. With a certain probability, the susceptible individuals are exposed to the virus. With a certain probability, those that are exposed to the virus get infected and are also infectious. And then with a certain probability, those that are infected and infectious get retired from the system, either because they recover or because they die. And for COVID-19, all these different probabilities have been estimated, and we actually tuned SAIR metapopulation model for the Valencian region, but we also modified it to take into account the mobility that we had from the mobility analysis. And this is an example of the kinds of predictions that we were doing every day with the SAIR metapopulation model. We also developed an agent-based epidemiological model based on the REINA framework. Here, the main difference is that instead of modeling meta-populations, you actually model every individual. So we have 5 million agents because the region has 5 million people living in it, and it has the same demographic profile as the region. And then the agents have a contact matrix that determines their social relations. And then there is, again, the same probabilities of being exposed and being infected and so forth. And then you run simulations with all these agents, and then you get a different epidemiological curves. And we've also not only developed an agent-based model for the region, but also a model that is able to take into account the different non-pharmaceutical interventions. And then the last model was developed in the context of the XPRIZE Pandemic Response Challenge that we participated in between the end of November of 2020 until the end of February of 2021. This was the shortest XPRIZE competition ever. And we thought it would be an interesting experience for us to participate because it would really push us to sort of like the next level. We had to build a model to predict the number of cases in 236 countries and regions in the world. So a lot more than what we had done so far, which was only in the Valencian region. And we also had to build a prescriptor of interventions. So a system that would actually recommend public policies that would be the optimal policies in terms of the trade-off between the cost of the policies and the number of coronavirus cases that would result from applying such policies. So we participated as the Valencia IA for COVID-19 team, and it was an incredible experience. It was the first time ever we participated in any kind of competition of this kind. And as I said, we were a team that we had never met in person before, and we didn't meet at all during the XPRIZE either, only using like technology. And it turns out that we actually won the XPRIZE competition. So that was really amazing for the team. I think it was the first time that a Spanish team won an XPRIZE competition. And the model that we built for the XPRIZE was a LSTM-based model that had different branches. So we had one branch that you see on the bottom that is modeling the non-pharmaceutical interventions, because we had to build models of the number of cases in the 236 regions and countries in the world, taking into account the non-pharmaceutical interventions implemented in each of the 236 countries and regions in the world. So it was quite challenging. So we had the bottom layer modeling the non-pharmaceutical interventions, and we had the top layer, and we built a bank of LSTMs. That was the result of clustering all the countries in the world by the dynamics in the number of cases, and we obtained 8 clusters plus a reference model that was sort of like a model that we used for most of the countries, but then because there were countries that had very different dynamics, then we used, we assigned different clusters to different countries depending on their dynamics. And this model actually worked really well. In terms of the mean rank, we were the 3rd best globally during the competition, the 1st in all the countries in Europe, and the 1st in all the countries in Asia. But the most valuable element of this is that we were able to use this model during the 3rd wave of infections in the Valencian region of Spain, which took place right after Christmas and was the worst wave of infections ever. Actually, the Valencian region was the 2nd worst region in Europe in terms of cumulative incidence of cases. And our model was extremely accurate. You can see here in blue the predictions of our model, and in yellow the ground truth, and in red the predictions of a competitive neural network-based model. And as you can see, it was very, very accurate, and it was extremely useful to the government to really have a sense on when we were going to reach the peak of infections and how many infections to determine whether the interventions that they have deployed were going to be enough or we needed to do more. And because with this model, we can apply and change interventions and run simulations. We did a lot of simulations of what if scenarios, or what happened if we close schools, or what happened if we do this, or what happened if we do that, is it worth it? And that was really very helpful to them. The third area, actually, sorry, before I explain the third area. So within the X-Prize competition, the semi-final phase was building this predictor of cases, but the main goal of the competition was to build a prescriptor of policies, sort of like an artificial politician in a sense. So to do that, we had to solve a multi-objective optimization problem where we had 2 competing objectives. One is minimizing the number of cases, and the other one is minimizing the economic and the social cost. And the idea was to be able to identify the Pareto optimal set of solutions, which in this case are public policies that would have the best trade-off between their economic and social cost and the number of cases that you would obtain if you applied them. So we did that combining different strategies to identify this Pareto set of optimal policies. We had to recommend up to 10 different policies along the Pareto front, and we had computational constraints. We had to do it in less than 6 hours for 236 countries and regions in the world for any time period that the organizers decided to do, and for any costs that they wanted to do. So the costs of the different policies was an input, because of course closing the public transport in the, I don't know, in England, it was the same as closing the public transport in a country where maybe public transport is not very much used, right? So the costs are country dependent. So we built that, and we also built some really nice visualizations that the policymakers could use, where in the visualization you could see the 10 policies along the Pareto front, which are these 10 color dots that you see on the top, and then you could click on any of them and see how many cases you could get. You could see what NPIs are active in that particular policy, and so forth. And that was really helpful to understand the impact of the different NPIs, non-pharmaceutical interventions, on the number of cases. The third area has been building predictive models, and we focus mainly on building sort of like predictive models of the hospital occupancy, intensive care occupancy. And we've done different methods, including also using LSTMs. And we use that a lot during the third wave of infections. Every day, we build predictions on the number of intensive care units, the number of patients, both overall and COVID-19, for every department of health, for every hospital, basically, in the Valencian region. And the last area is a very large-scale citizen survey called the COVID-19 Impact Survey. And the reason why we launched this survey is because there were very important questions that we wanted to answer that we couldn't answer because we didn't have any data source to answer them. For example, what is the social contact behavior of people? What is the psychological impact of the pandemic? How resilient are people to all these confinement measures? What is the economic and labor impact on people's lives? What's the prevalence of symptoms? You know, is contact tracing working or not working? What are the individual protection measures that people adopt? Do people use masks? Do people limit contacts? Do people focus on ventilation? What's the intention to get vaccinated? I mean, there were so many questions. So in March of 2020, we decided to launch this really large-scale citizen survey, also to give people a voice and to give an opportunity to people to speak out and to share their experience. It's a fully anonymous survey. I encourage you to fill it out. You can fill it out ideally every week because, of course, our situation changes, but also the pandemic changes every week. And it's translated to many different languages. It has 26 questions and is super, super helpful. The survey became viral. We got over 140,000 answers in 40 hours since we launched it. And we felt so impressed by this overwhelming response by the population that we very quickly wrote a paper where we share the data from the first week of analysis, and we share the main insights from this first week of analysis, and most of the insights apply to the rest of the pandemic. Since then, we've been analyzing the data every week, and we have built a number of visualizations, and the one on the right-hand side is the one that we keep updated every few days. We update it with the new data, and most of the findings from this paper apply. So I recommend you to look at the paper if you want to know more about what the impact of the pandemic has been on people's lives, at least in Spain. I don't have time to go into more detail right now. I had more information about some prevalence inference that we've done that was very useful in the first wave when there weren't any tests for the government to understand what was the actual prevalence of the disease. And then I have some interesting insights from the survey, but I won't be able to explain to them. But I encourage you to look at the website, at this website here, and maybe you can look yourself at some of the insights. But we do have sustained evidence on how the youth is the demographic group that is the most impacted emotionally by the pandemic. We have been advocating for youth programs since April of 2020. They are the demographic group that reports the highest levels of anxiety and stress and loneliness and sadness than any other demographic group. We also have the evolution of the perception of the government measures, which is interesting, obviously, for the government. We have information on how, with protection measures, people adopt, and maybe the most interesting insight from Spain, because it's different from other countries. We also have data from Germany, and Germany is very different to Spain. Is A, the population is very compliant in Spain in wearing masks, in the keeping distances. B, the population in Spain is very keen on getting vaccinated. We have right now, I think it's almost 90% of the population wants to get vaccinated. And then C, women are significantly more compliant than men in most of the protection measures. Women report wearing masks more often and avoiding crowds and ensuring there is ventilation than men. And this holds for other countries. But what doesn't hold for other countries is the high levels of compliance and the high levels of wanting to get vaccinated, which, for example, in Germany are much, much lower than in Spain or in Italy. Another important observation is the perception of risk of different activities, how it has evolved over time. Very consistently, the activity that is considered the safest is doing sports individually, and the activity that is considered the least safe is flying by plane in terms of the probability of getting coronavirus, even though I don't think there has been any reported outbreak in planes, but this is, you know, the perception of people. We also have information about the context of socialization. It is indoors, outdoors, with protection, without protection. And we do have very significant evidence that the third wave of infections was due to the Christmas holidays and how people had a very high percentage of interactions in indoor environments without any kind of protection measures. We have evidence since April of 2020 on the ability of people to isolate themselves. One of the key control strategies for the pandemic is the TTI strategy: trace, to know whom to test, to know whom to isolate. And one of the weak points is that roughly 50% of the people aged 60 and younger are unable to self-isolate, mainly because of sharing their homes, but there are also gender and age differences. There is a significant age difference in terms of psychological reasons, where the youth reports psychological factors a lot more than any other group, both not being able to psychologically isolate yourself and also fear of a stigmatization because of having COVID-19. And we also identify a very important gender difference in the reason not to be able to self-isolate because of having to take care of children, which you can see in the middle column, the orange bars, where more than twice the women say that they wouldn't be able to self-isolate because of taking care of children than the men of the same age range, which is really a very significant evidence on how the burden of childcare has been on women during the pandemic. We have evidence of the impact of the contact tracing app in Spain and also in Italy and in Germany. And in the 3 places, the impact, according to the survey, is minimal from an original sample of over 100,000 people, of which, almost 38,000 or 39,000 had the app installed, and the app only helped identify 7 positive cases, according to the answers to the survey. So there definitely was difficulties with the app, at least in Spain and Italy. And just to wrap up, I think what I have learned during this pandemic is that a pandemic is not a public health issue. It's a societal challenge that requires a holistic approach. And I think we have a huge opportunity that we haven't realized to create a virtuous cycle between these 3 elements, between data that is systematically captured and analyzed to understand where we are, why we are where we are, and predict where we are going, and try to figure out how we can anticipate where we might be going. Then also people and technology, having the right teams, with the right numbers of people, the right capacities, but also the right technologies so they can actually do their job. And then ultimately what we want is to define public policies that are addressing weaknesses that we have identified, with all this data and people and technology. So if we know that the youth is suffering, let's create programs for the youth. If we know that people cannot self-isolate, let's really create programs to support people, with self-isolation, and so forth. Reflecting on all of this, together with Manu Letuse and Data Pop Alliance, in collaboration with the Vodafone Institute, we wrote this publicly available paper that I recommend you to read if you want to know more about our views on how we can use data and technology to fight COVID-19, and what are the sort of like the key recommendations moving forward and thinking about the future. And we also have a lot of publications on the topic if you are interested in knowing more. And with this, I have to wrap up. So thank you very much for all your interest, and I hope that you enjoyed my presentation.
Thank you very much. Nuria. It was a very, very interesting talk, covering many aspects of the COVID-19 response. So here I will ask a few questions. So just a reminder to the audience that if you want to ask a question, you can just write on the chat, and I will tell it to the speaker. So the first question I have that a participant has is about, you had the slide about the challenges in creating a team that can answer a crisis like the COVID-19 case. And the fact is that this concern and challenges are probably familiar to anyone that has done data science or AI projects. And the question of the audience was, can you share some of your learnings in how to approach these challenges?
Yeah, so I think some luck factor, or maybe the alignment of the stars that happen in the Valencian region, is that we had a very receptive president and president cabinet regarding to creating an effort like this effort. And the reason why they were very receptive to this is because for a few years prior, they had already been working on how artificial intelligence is transforming society and how it is transforming our sort of like production systems. And they published the artificial intelligence strategy of the Valencian region in November of 2019, over a year before Spain published their national AI strategy. So the region has been really advanced and really focused on how AI, and when I talk about AI, I mainly talk about data-driven machine learning methods. So AI and data are key to sort of like progress and to the future of the region. So we had, there was all this previous work on the value of data, on the value of the region. So in the strategy, which was published before the pandemic, there are 3 big areas of focus sort of like that the government wants to focus on in terms of AI. And the third area is the use of AI in the public administration. And they had a commitment on a lot of ideas on creating a data science team in the public administration, on leveraging data to help make better public policies and make better decisions. So when the pandemic happened, and when I offered to them this idea, there was the right environment, because they had themselves committed a few months prior that they actually wanted to be able to leverage the data to support their policy making. There was also a trust relationship, because I collaborated with them for, in the AI strategy, and I had collaborated with them before. So they also knew me and they trusted that, we could do a good job. So I think these factors played a key role in the government being very willing to very quickly create this team and work very closely with this team. I have to say that the work that we have been doing has been sort of like as volunteers. Later on during the pandemic, we applied to 2 competitive research funding grants by 2 different institutions in Spain, and we got both of them. But our original motivation and our original way of working was as a volunteer work to really try to do our best, in helping. So I think it is very important to have the trust and to have the belief and to see the value in the public administrators and in the policymakers. If that is not the case, I think it's very difficult to have impact, because at the end of the day, they have to understand what we're doing, and they have to value it, and they have to know what to do with it, and I think that can only happen if there are members, as I said, members of the government embedded in teams like these. And I mean, of course, moving forward, to have a sustainable effort like this, they will have to create a data science organization within the government. But this is something that they are actually planning on doing. It just takes a long time. There's another learning from this experience. The public administration moves really slowly. And of course, the pandemic moves really fast. So I think we were able to achieve so much also because we were an independent body. We were just like a volunteer body working with them, but not within the public administration. So we were not subject to all this bureaucracy that usually involves doing projects within the public administration. So that was also another key element for our success. We were individuals, of course, with our own affiliations, but individuals volunteering in this joint effort. So we could make decisions like, we don't have to ask permission to anyone. Let's do this, let's do it. Let's do that, let's do it. Oh, now, let's go to the X Prize. Okay, we go. And that was really another key element, that we had zero bureaucracy in the team, a very flat structure. We, as I said, we met every day. Everyone, we met multiple times a day, many days. Everyone did whatever they could. We used Slack a lot, but we were in a very collaborative, sort of like flat kind of like structure where everyone was doing, whatever they were doing. And I was sort of like putting all the pieces of the puzzle together and writing all these reports and making sure, that all the work was sort of like aligned. And I think that was also another strength of our team, the fact that we didn't have to deal with any bureaucracy. And definitely the fact that we had a very committed, very active, and very savvy member of the government as part of our team.
Thank you, Nuria. So we have many questions arriving. So the next one I would like to ask is, after the experience with the COVID-19 pandemic, do you think that the policymaker and the telco industry will be more ready to face the next pandemic? Hopefully we won't have one in the next future. For what concerns data sharing, data analysis, and policy making? And finally, are we in a better position now to face future emergencies?
Yeah, so I want to believe that we are. Actually, I think that one of the sort of like long-term positive impacts of this horrible pandemic is the acceleration of the digitization of the public administrations. I think what has become evident during the pandemic is that most companies, particularly large-scale companies, had already become digital, many years ago. Most of them had undergone that transformation, and they had also become data-driven. and they had, central teams of data science teams, a chief data officer, and so forth. None of this had happened in the public administrations yet. And I think with the pandemic, they have realized that, that was definitely a key weakness. And I think with the, in Europe, with the European reconstruction funds, part of these funds are actually going to be for digitizing the public administrations and accelerating this necessary transformation. So they can support their policies on evidence, which is what we all want, as opposed to supporting them on, I don't know, intuitions or obsolete knowledge or political interest, right? So I do want to believe that this pandemic has definitely contributed to accelerating that process, but I think we have suffered a lot, the ones that we were trying to do sort of like data-driven analysis, because of the lack of this digital culture and data culture. I mean, just to give you an anecdotal example, at the beginning of the pandemic, when we were trying to build all these models, and of course we needed data to build the models, their understanding of data was sending us a PDF with a table. And we were like, well, this is not data. This is a PDF with a table. I need wherever you got this table from, that place, that's what I need. And it took us a long time for them to understand that, we could actually directly try to access some place with the raw data so we could actually analyze it with the algorithm. So yeah, the level of digital literacy and data literacy wasn't very high. It wasn't part of their day-to-day work. And I think it's definitely a lot more now. Yeah. Also for citizens, I think this pandemic, I mean, I don't know how it's been in other countries, but I mean, in Spain, every day, everyone hears the figures of percentage of vaccinated, cumulative incidents in 2 weeks per 100,000 inhabitants, this and that. So there's a lot of data that is being shared with people as well. And so I think overall, the population has also become more data oriented in understanding that you can define indicators, sort of like objective indicators that will drive the definition of different policies. So if we are within these, below these thresholds, we can have sort of like a normal life. But if we go above these thresholds, then we have to activate some kind of, level 1 or level 2, right? And I think that has also become more the part of the way of thinking in citizens as well. And I don't think that had happened before. At least definitely not on such a daily basis and so broad, right, for everyone. Yeah.
Okay, thank you, Nuria. So I guess we can conclude we are in a better situation than before. I'm sorry there were a couple of other questions, but we are running out of time, so we'll have to stop here. So thank you again, Nuria. It was a very nice.
Yeah, they can contact me per email if they want. I forgot to mention that the paper describing all the work that we did for the X Prize has been accepted to ECML PKDD. So we'll have the paper public like in a couple of weeks. I think the camera ready is due this week. So we'll put it on archive also as soon as we have the camera ready. And there we have a lot more details on the actual architecture, performance, everything that I have time to explain today.